Hello everyone and welcome to our Computer and Network Security Projects presentation. Our project is called BioAuth. BioAuth is a behavioral biometric continuous authentication system integrated into the Algeria Wilayas Explorer platform. The goal of this project is to solve a major weakness in modern authentication systems. Identity verification usually happens only once during login. Our system continuously verifies the active user during the session by analyzing behavioral patterns such as mouse movement, type-in rhythm, and scrolling behavior. Most modern web applications authenticate users only once. After login, the system assumes the same legitimate user remains active during the entire session. This creates major security risks. If an attacker steals credentials or a valid session token, they gain full access without traditional verification. Traditional MFA improves security but introduces friction through SMS codes or authenticator apps. At the same time, biometric systems based on fingerprints or facial recognition raise privacy concerns because they require storing sensitive biological data. The challenge we addressed was, can we continuously verify user identity in a way that is passive, privacy-preserving, and user-friendly? BioAuth is our solution to this problem. It is a continuous authentication layer based on behavioral biometrics instead of repeatedly asking users to verify themselves. BioAuth silently observes how they naturally interact with the application. The system builds a behavioral fingerprint using mouse dynamics, keyboard timing patterns, scrolling behavior, and session interaction patterns. If the behavior significantly deviates from the learned profile, the system automatically triggers a security challenge. BioAuth follows a three-tier architecture. The front end contains the biometric collection engine, written in JavaScript, which passively captures interaction data from the browser. The backend uses Node.js and Express for authentication and session management. The machine learning microservice is implemented using Python Flask and scikit-learn. It analyzes behavioral vectors using the isolation forest algorithm. Finally, SUPA-based PostgreSQL securely stores behavioral, profiles, and session data using row level 1 security. The system continuously collects interaction data across 5 channels: mouse movement, cursor speed, acceleration and direction changes, keyboard dynamics, key hold time and flight time between keystrokes. Importantly, we never store typed content. Mouse clicks, click frequency and click hold duration. We also analyze scrolling behavior and session metadata, such as idle periods and tap switching activity. Every 20 seconds, this data is transformed into a 16-dimensional behavioral feature vector. BioAuth uses a hybrid anomaly detection system. The first method compares current behavior against baseline average to detect large deviations. The second method uses Z-score analysis to identify subtle statistical anomalies. To reduce false positives, the system requires 2 consecutive anomalous windows before escalation. In addition, we implemented a machine learning microservice using isolation forest. The model learns normal user behavior and automatically detects unusual interaction patterns without requiring attacker datasets. Now, let's move to the live demonstration of BioAuth. Here we can see the Algeria Wilayas Explorer platform integrated with BioAuth. After login, the system enters its learning phase and gradually builds the user behavioral baseline. As I interact naturally with the platform by navigating, scrolling, and typing, the system continuously verifies the session silently in the background. Now, we will simulate a suspicious behavior by intentionally changing interaction patterns. As we can see, the anomaly score increases because the behavior no longer matches the stored profile. After sustained abnormal activity, BioAuth triggers the security verification overlay. The user must answer a configured security question within the countdown period. If verification succeeds, the session continues safely. Otherwise, the system automatically logs the user out. During testing, BioAuth successfully mitigated several attack scenarios including credential theft, session hijacking, unattended services, bot attacks, behavioral replay attacks, and baseline tampering attempts. Unauthorized behavior was typically detected within 20 to 40 seconds. To conclude, BioAuth demonstrates that continuous behavioral authentication can be practical, privacy-preserving, and user-friendly by combining behavioral biometrics, statistical anomaly detection, and machine learning, the system transforms authentication from a one-time event into a continuous security process. BioAuth proves that strong security does not necessarily require intrusive user experiences. Thank you so much for watching.